Hello and welcome. My name is Philipp Rudiger. I'm a senior software engineer at Anaconda. Today I'll be talking about scalable cross-filtering dashboards with Panel, HoloViews, and hvPlot. So before we dive in, what is cross-filtering? Cross-filtering is the ability to select data points in one plot and having those selections be reflected in other plots. It's also known as link brushing, and it really allows you to get a grip on multidimensional data sets by showing many different views of the same data and how they relate. So particular as data sets get more complex and have interrelationships in many dimensions, it's really useful to be able to kind of drill into them and see how different dimensions relate to each other. And that's what we'll be seeing today. So I'll be picking apart the title bit by bit. So what we're going to be starting with today is cross-filtering with HoloViews and hvPlot. In this first example, we're going to be building interactive plots and start with three main libraries. We're going to be using Pandas to load and manipulate the data, HoloViews to link our selections between the plots we generate automatically, and hvPlot to quickly generate plots using an API that you're familiar with. So hvPlot is very much mirrored on the pandas.plot API, and so if you're familiar with that, it's going to give you a very familiar experience. But instead of outputting matplotlib plots, which are static, hvPlot generates Bokeh plots, which you can interactively work with. So we're going to be starting by generating a few plots from the Palmer Penguin dataset, which is a really nice open source dataset, which was recently open sourced, in fact, which represents measurements about various penguin species, particularly 3 species, Idle penguins, Gen 2 penguins, and the third one I forget, but we're going to be seeing that in a minute. So it has measurements about their beaks, so the length and, for example, width, their flipper length, their body mass, their sex, and more information. And so this is a fairly complex data set, and we might want to get a handle on how these different dimensions relate. So we might generate a very simple plot here. We're going to be using hvPlot. So just like .plot, we can use .hvPlot and generate a scatter plot of their common length versus their common depth. So just as a reminder, this is in fact their beak, measurements about their beak, and we're going to be coloring this by the species, give it some fixed colors so that things don't, so we can clearly distinguish them. And now we can see here we got out a Bokeh plot that we can work with. So we can now zoom and pan around, we can hover over the data points, we get more information about the precise measurements, for example, and their species. So the third species I forgot about before are chinstrap penguins. So this is nice. And as a first view, it clearly distinguishes these 3 species, but we really want to dig in a little bit deeper. So another thing we might want to do is generate a histogram. Here we're going to be generating a histogram of their body mass, again, colored by species. And we can see here, you really have non-overlapping distributions of body masses. And again, we get an interactive plot, hover information, counts in each bin here, and we can zoom and pan around. Okay, but how do these two relate? Well, we can find out using this HV linked selections function. So we can make an instance of this, and we'll see how that comes in useful later. Really, we could just do this in this particular instance. We're going to be composing the histogram plot and the scatter plot, the plus operator in HoloViews, which is what hvPlot outputs, basically puts plots side by side, or in fact into a grid, which allows us to lay them out very easily. And the link selections function basically just takes these objects and automatically adds link selections to them. So what we get here, and what we didn't have in the previous plots, were these select tools. So we have box select and we have lasso select. If we do perform a selection on one of the plots, we can see it's automatically reflected in this other plot. And we can use both box and lasso select to view different parts of this distribution. The other nice thing is we can select the selection mode here, i.e. this tells us how to combine different selections on one plot. So far, we've kind of had the replace mode, where it just replaces the current selection. We can also combine selections. That was So we use clicking. We can also combine selections. So here, for example, I can add a selection. I can combine multiple selections to basically get more control. Alternatively, we can also get subtract from their selections. So let me actually clear the selections, reset everything, and then we're going to select this subtraction mode. So if I start by making a lasso selection, which tries to include most of the points. In fact, it's the inverse, so I slightly got that wrong there. But now, if I further try to subtract from here, so for example, I don't want these points in my selection, or this particular point here, I've now completely excluded the chinstrap species. Right? So in this way, we can really combine multiple selections to kind of drill down to exactly the data points that we're interested in. And we can also combine selections across plots. So if I select on here to, for example, only include higher body masses or exclude higher body masses, we now get just our Adelie species. This also works for other plot types. Right? So far we've seen the scatter plot, we've seen the histogram plot. We can basically reflect the selections in any type of plot. And so we can, for example, just select here, and we can see here in this bar plot, which basically just counts. It's a count of all the individuals in each species. And we can also see the distribution here in this violin plot, which is split by sex. So we can see how the distribution changes as we select among other dimensions. So for example, if we select only low body mass, we can kind of see how the distribution of flipper length also shifts downwards. So we're really getting at how one dimension relates to another dimension. And we can drill down as deep as we want. Okay, so that's pretty nice. We can work with a variety of plot types, but we can also work with different data types. So here, we're going to be loading a data set of air temperatures using the Xarray library. So if you're not familiar with Xarray, it's basically a multidimensional pandas. You can kind of think of it as that. If you have multidimensional arrays, in this case, we have basically measurements over the US recorded over time. So you should think of it as a 3D array. And if we specify to hvPlot that we want to plot this as quad mesh, and use the longitudes and latitudes, it realizes there's one dimension left over here, which is the time dimension. So here we get this time slider that allows us to scrub through this time axis. Let's see how these temperatures evolve over time. Similarly, we're going to be generating a histogram plot here, and we're going to also be grouping that over time so that we get the distribution of temperatures for a particular time point and kind of can select on it. So again, we simply apply our link selections function here to this composed layout of these two plots. And if I do that, so for example, I'm only interested in higher temperatures, just below 300 to 310 Kelvin, we can see here that this selects here the southern regions of the US and some of the Gulf, I think is what this is. And so now we can see how that distribution shifts as we scrub through this time dimension. Right? So we can really get at how these two variables relate. And we can also do the inverse, right? We can say, well, really, I'm interested in a particular region of the US, so for example, the eastern seaboard, and I want to see how the distribution of temperatures there evolves over time. So we apply a lasso select, which applies that region, and we can now see how the distribution of temperatures changes there over time. So again, these two plots individually are, of course, useful, but adding the ability to do link selections really allows us to drill down and kind of look at subsets of the data and see how different variables relate to each other in that particular subset of data. So really, at this point, you should have learned that really the link selections are very general. They apply to all kinds of plot types. Basically, most plot types in HoloViews and hvPlot are supported. And they really let you drill down on the data. Okay, so we've now seen what link selections can do for us. But part of the whole promise of this was that this would be scalable. So how do we scale this? So far, we've dealt with relatively small toy data sets, but now we want to scale this up a little bit. How do we go about this? Well, two libraries will come in useful here. We can use Dask to basically scale our Pandas data frames up and out to multiple cores or to a whole cluster. So if we can kind of work with data sets much larger than we could deal with on a single core with Pandas. Or we can use Rapids QDFs to really even move the computation to a GPU. So the nice thing about hvPlot is that all these different libraries here, you see here, kind of feed into hvPlot, the .plot API, and you don't even need to change anything about your code. You simply change the data frame type. So you use a Pandas data frame, or you use a Rapids QDF data frame, or you use a Dask data frame, and things just work. You don't need to change any of your code. That then feeds into HoloViews, which is the intermediate representation of this. And then optionally, we can feed this through Datashader, which allows us to scale this to much larger data sets. So if you think about it, if you were to drop tens of thousands, hundreds of thousands, millions, or even billions of data points in your browser, it would just crash. And so what Datashader lets you do is it provides a way to very quickly aggregate our data into a 2D view. So you can sort of think of it as a 2D histogram. And then that fixed size image gets sent to Bokeh, and we can zoom and pan around and kind of interactively explore data much larger than your browser could ordinarily handle. And this is all wrapped up nicely in the hvPlot bundle. So what we're going to start here with here, and we're going to hide this ugly warning, first of all. We can see here, we're loading this New York taxi data set from a Parquet file, and here we're going to be using Dask to do so. So this load data function would also support QDFs. This particular machine doesn't have a GPU, so I'm not going to do that. Or we could use Pandas. But to demonstrate some of the scalability, we're going to be using Dask. And so in all three cases, we get back a data frame containing 11 million data points, or 11.8 million to be exact. And this could be hundreds of millions or even billions of data points. And depending on your particular GPU or how many cores you have or what cluster you're scaling out to, this would work fine. So we're quickly also going to be looking at this data. And we can see here we have drop-off times and dates, the number of passengers, trip distances, pickup locations, drop-off locations, fare amounts, tip amounts, so on. So there's quite a bit of data here, and we might want to see how that data relates to each little bit, right? And so getting at this with a cross-filtering view with just a regular plot is kind of difficult. So what we're going to be using here is we're going to be using the hvPlot function in particular. So this is hidden behind these options here, but we're going to be using Datashader equals true. And so this is using Datashader in the background, which aggregates our 11.8 million data points, which would ordinarily just crash things. And now we can zoom and pan around and even drill down to individual data points, right? But we still get this really nice overview at the zoomed out level. So we can still see all our data. It's all very interactive. And this is all scaled by Dask. So this would work just the same on the GPU, only it would be even more responsive. And so now what we're going to do is we're going to apply a selection here on the pickup locations. And we're going to see that get reflected on here. So this is taking a bit longer. We can see that reflected on this side to see where people who got picked up at the airport here got dropped off. And we can see here there's these dense clusters in downtown Manhattan. And so the explanation for this is, in fact, that a bunch of large hotels here are in downtown Manhattan. So immediately we can kind of gather more information than we ordinarily could just by doing some selections here. And so we can glean more information about this data. And so the way this works in the background is, again, we've generated our plot with hvPlot. The linked selections here, we've made an instance so that we can apply the linked selections individually to these two elements. And in the background, basically, as we apply different operations, such as data shading, HoloViews keeps a pipeline of the operations that we've applied and then replays those given the current selection. Right? So in the background, we still see the full data set. And then in the foreground, we see a view of the current selection fed through the same pipeline that the original data was. And so in that way, we can basically perform linked selections on pretty much any kind of data and any kind of plot type, including complex plot types such as these data shaded plots you see here. So another thing we're going to be doing here is generating a few histograms of some other variables in this data set. So for example, the trip distances, the fare amounts, the pickup hours, the drop-off hours. In fact, some of that is cut off here, but that's okay. So now we can kind of select on different attributes in this data set. And again, we're basically generating our plots here. We're iterating over these hist ranges, which basically tell us what range we should aggregate. We're using hvPlot.hist. And then finally, we again use the linked selections object that we defined previously. We made an instance before. We apply that, and now we get a column of histograms that we can reuse in a little bit. So again, using just very few lines of code, we've generated kind of quite a few views of this data, and now we get the task of laying this out nicely, right? And that's where the panel library comes in. So if you're not familiar with panel, we're now going to be building a dashboard that you can deploy in different scenarios. The panel library is meant to make it easy to take your exploratory workflows. So you've done some work in a notebook or in a script, and now you want to share it with someone. So this has often been difficult in the past, but panel makes this easy. It supports a wide range of visualization types, plot types, and you can simply combine it with panel and then prototype it in a notebook, kind of go through that feedback loop of, I want to adjust this a little bit, I want to fix this. And then finally, because panel is built on top of Bokeh, we can simply deploy it using the Bokeh server. So that's really nice, and we're going to dive into what that looks like a little bit. So panel has really powerful APIs, and one of those APIs is the panel depends method. So panel depends basically says, I depend on some variable, and if that variable changes, re-render this view. So in that way, it's reactive. It's a bit like Excel, right? You define some dependency on some other cell, and when that cell changes, it updates. So pn depends here. What are we depending on? Well, we're going to be depending on the selection on this data frame. So again, we're reusing the selection linked selections instance to say, give me a parameter that changes whenever the selection changes, and then return the currently selected data out of this data frame. And so that's what we get here. We basically get a data frame reflecting the current selection. And if we show that, we can see here, we're basically just formatting the total number of trips, the selected number of trips, and then the average trip distance in that selection. And then when we, for example, go back a little bit, I'm now going to just be selecting trips basically up to 4 miles long. So that's going to take a little second because all of these plots that we saw before basically were linked, including the other plots, the geographic plots that we saw before. And so now we can see here, we've basically selected a subset of data. And we can see here the average trip distance has dropped significantly as well. So as we said before, the panel supports a wide range of not just plot types, tables, and so on. It also has various widgets and indicators that allow you to indicate various things about the data, right? So here we're going to be using, or maybe abusing, the progress widget, which is meant to give us some indication of progress, to basically show the fraction of data that we've selected. So here we can see we've selected most of the data, and it gives us a nice quick visual indicator. And this is just using the same API that we saw before. So we're depending on that current selection, and then return this progress widget, which updates whenever we perform any selections. All right, well, okay. So now we've built various components, and we want to put this together into a nice dashboard that we can share. Since panel 010, which was very recently released, and we now have the ability to use so-called templates. So here we're going to be using the material template. We're going to be giving it a quick title, give it a logo, give it a theme, and then we're going to start composing our actual dashboard, right? So we're going to create a quick header, put a little spacer in there, our counting. If you remember, this is the little bit that tells us about the number of trips that were selected. We're going to be laying out our plots side by side and ensure that the axes aren't shared. And then here comes the actual composing of the template. The template comes with some list-like objects, which we can simply append to. So here we append our header to the header object on this template. We append our histograms to the sidebar here, and then we append the plots to the main area. And so in just a few lines, we've populated this template with the various components that we've been writing up. So now we're going to be switching to that deployed version. So here, I basically set .show, which basically launches a Bokeh server and opens it in another tab. Alternatively, we could be using servable here, and this would basically mark it so that on the command line, we can run this with panel serve and then point it to this notebook. So in just a line of code, we can make this whole thing deployable. And so if we look at that, maybe we're going to have to rerun this. Might take a little second. But basically, the panel architecture makes it easy to kind of prototype and play around in the notebook, compose different plots, and then plug it into this nice little template, which we can deploy and view. Okay, so now we've opened this dashboard. We can see here, this is really quite a nicely laid out dashboard. We get our sidebar, which we can collapse. Everything is responsive. And we see our trips here. We see our geographic plots here. So once again, we could kind of select some subset of the data. We're again going to select here on the airport and see what that selection looks like. Now we can see the distributions here in the histograms here to update to reflect that selection. And so that's quickly gives us an idea of how trips here at the airport differ from trips otherwise, right? And so we can, for example, see the trip distances are much longer from the airport, which makes a lot of sense. We can again see the distribution here change quite a bit, and so on. So we could further narrow that down and say, really, well, I'm only interested in really low fares. So $4 to $6. Where did people go from the airport on from $2 to $6? And so again, makes sense. Only very short distances show up now. Very short distances here. I think I kind of broke the selection, so we're going to reset this. What you probably can't see here is also that we get a little progress indicator, but I'm probably currently just hovering over my own image, so that's fine. So yeah, just within a few lines of code, we generated this really quite complex dashboard from the components that we defined in our notebook. All right. At this point, I really need to thank the organizers of this conference. I'm very excited for various talks. I also need to thank John Meese, who implemented the first version of link selections. And I'm really looking forward to your questions in the Q&A sessions. Thanks very much. I hope you learned a lot, and please try out our tools. Thanks very much.